week 11. Week 11 until like 30th June. Is it? Yeah, 30th June. This Sunday. So week 11 quiz, and which is carries 14 marks. Okay, so what is on week 11 quiz? Whatever we covered week 3, 5, 7, 9 is going to repeat on week 11.
How many?
Okay, so 100% repeat, but not the same question.
Oh, okay.
But the format still the same. So whatever you studied or faced on 3, 5, 7, 9, and you, I believe you know your answer as well. Not only you attended, now you know what is the answer for all the things. So keep it as a reference of all the quiz answers before you open up week 11. Okay. So anybody attended? Not started? Okay, good. That is this weekend. It's very fast, but I think week 11 we have more time because there's more question is there. Okay.
How many questions?
So let's go on it actually. How many questions and how long it is. So right now we are on week 11 quiz. Let's explore about week 11 quiz.
Cái YouTube luôn.
Okay, so as a student view, yeah. Okay, maybe I will go student. Okay. Right now you can look, right?
Yeah.
Available until yes, correct? Oh yeah. So week 11 right now what we see is 90 minutes, 1.5 hours timing and 10 questions, okay, and overall points is 14 and it's already started until Sunday night, okay. So basically the time duration is 90 minutes and 10 questions you are going to face on it, and the overall only one attempt for this quiz, okay. Once you start the quiz, the time start already. Okay, so as long as you're comfortable as like previous quizzes, do the same thing, no disturbance when you are doing it actually. Okay, and I'm going to share one of the slide today, which is belongs to week 11. Okay, so maybe first I'll go through week 11 quizzes, and I believe you also have the existing slides, which is until like week 3, 5, 7, 9 quizzes which I shared. So this one I will share which is more towards week 11 review quiz. Okay, the typical question is like that. Maybe the numbers will change. So let's go on it. First week 11 quizzes, which is currently are going through. Which is over here, week 11 first question is trying to reflect. You try to use a MATLAB, okay? So the transfer function is given. I believe now you are able to refer our last session to type how to type the transfer function, then how to call the graph, Nyquist plot, then you can get it actually. Okay. So by means you can able to get the graph. Over here the k value they didn't specify. Okay. K equal to 1, 2, 3, you can specify and see how the graph look like on your MATLAB screen. Okay, from there you can roughly compare, then see what will be the K value. Now for this K value is 6. So I mean like when I put it like K value is 6, then I run the MATLAB, I will able to get it this kind of graph. So based on MATLAB graph, then you can key in the information over here. Okay, so questions, are we good? So MATLAB Nyquist plot, I believe from our last session we have a plot on it, Nyquist plot. Let me open anything so that, yeah, it's something. So you have a numerator, denominator to call for the function, and we have system so-called transfer function, so that you know your equation already received. By just giving Nyquist, you get the graph already. Okay, then you need to have a different numerator, different k value. Let's say you can put it 10 or 20 or whatever it is. So then you can see running, you will get a graph. So compare with the quiz graph and your resultant graph. Then if it's almost similar, then you can able to key in the value. Are we good on this? Even there's one question I believe we also have, yeah, something like this. 9a example where you can put like k equal to 10. So I put it k values over here as a numerator, then denominator, then call for transfer function, then Nyquist plot. Okay. Even the axis is not needed, so it is not needed for your case. As long as plot made, then you can compare. Okay. So questions on the first one.
So the k value we are seeing.
We need to try,
Oh, try.
iteration.
Okay.
You try to put 1, then see the graph, then change to 2, then try the graph, or 10, see until
But
which
it won't be go up
it
to
won't
10.
go like 100, right?
Yeah.
So less than 10, I'll make it this.
So like need to get the same as that.
Yeah.
is it?
Yes,
Or-
you try to see similar. Then it's very simple to compare, where the -1 red dot is there, and then 5 to -4 within that graph will be achieving 8 to -8. Roughly you can see the overall limit where the curve is coming and the shape of the curve. Then you can finalize. It won't go more than 10, so but it's still iteration. If you want to make a one click itself, K1, K2, K3, then you can assign also. So if you really want to do it, we can compare our 8C coding. Let me don't say. I don't know, maybe somewhere put it. Yes. So you can try this way. 9C. So I put it like because I don't know what is the k value, so I can assign different k values, and I can get a transfer function. You can call Nyquist. One graph, everything is there.
One by one is better. Yeah.
Yeah, I will leave it to individual.
Yeah.
We have all kind of solutions.
Just change the number only.
Yeah, you change the number, run, change the number, run actually. So it won't take a long time.
Yeah.
Okay. So that's where the first question goes. In a way, like we have a curve, and based on the curve, you need to identify what is the constant number. Then you're trying to substitute the constant number on it, then submit. Likewise, you have our other question, which is we are trying to make our Nyquist plot. And here on this plot, they're given the transfer function and the curve and the transfer function. Okay, so transfer function 1, 2, 3, 4. So you need to identify transfer function 1 means which curve. Okay, so you need to select accordingly. Okay, so again, it's the same code, you just need to run. Then based on the functions, so you can able to pick either line A or line B or line C or D. Okay, which is roughly you can see how they given. Okay, are we good? Or any question on this? So basically, be familiar or trying to practice your MATLAB. At least whatever we given as an example, you just try to run. Okay, so then you can start your quiz. So are we good? Or we have any question on this? Okay. Then again similar. So it's called Nyquist diagram stability. Okay. So we have a stability issues which is system 4. Okay. Please check the stability of the system and choose a system which is unstable. How do you define is unstable? Stable, marginally stable, or unstable? Yes.
Not close.
Encircling the -1 or the red cross actually. Let me zoom it. You can see, of course, that's a maximum zoom we can go. Okay. So usually we can say as graph 0, and this is -1. Let's say this is -1. Okay. And basically when the curve coming in, it goes here is okay, even it comes here is okay, but as long as the curve encircle, okay, circling this part mean unstable. Okay, this is unstable. Okay, so right now you look the curve which is unstable, which is which curve? 3. Okay, so the red dot is here. Hope my cursor can see. So of course, system 2 is clear, no problem. System 3 is, okay, now curve is here.
Yeah.
So obviously system 3 is okay. Then system 1, it even come from here then close. So it is not even touching. System 1 also very clear over here. Whereas this orange color, system 4, it is coming and encircling. So system 4 is the issue over here, or so-called unstable. Okay, so we need to click that curve. Then this one, it doesn't really require to look on the MATLAB. You can just see itself, then you can click on it. So questions so far? Good. Okay, so this is more towards select the bot plot based on the omega with the following options. So we can say even it doesn't really need to look anything because it's S and 2S on the numerator.
On the line or
On the line is marginally stable. So when a curve is coming on the line is so-called marginally stable. There's a three cases will be there. One is unstable, one is marginally stable, this is stable. No problem. Okay? So that is the three cases what we are having here. So when it is not encircling, it is stable. When it is on the curve, on the -1, it is marginally stable. It can be stable, it can be unstable, so it is considered marginal. So if you end totally crossing -1, it is unstable. So that's how it goes. So only three cases on our last week's slide. It's one of the slides specified clearly. Encircling. So there's only three conditions specifying. Okay. Yes. Any other good questions? It's okay to recall. That's the purpose of the sessions. So if you are able to recall, so we can point out the slide where you need to reference. Okay, so this is come back to this bot plot. Is S and S, so it's obviously plus side. So that is what we see on the last session. So that is become plus 20. Multiplication is there. So 20 decibels. So it will be there. You just directly need to click. And here parameters given.
So can you go to the previous?
Yeah, go ahead. So basically what we will get it, first is 20 decibel, okay? If it is always going forward, okay? Or maybe you can say the numerator already have 1s means already have 20 plus 20. Okay, maybe just to pull back the slide we have from the last session. Maybe 4B, I think. 4B, of course. Okay, this is more towards MATLAB. Okay, this is polar plot. Bot plot is possible. Okay, so here specifying, let's take a look on it. Yeah, okay, sure. So as we know about the bar plot is logarithmic of amplitude ratio from the things. So if you look on here, K, also called gain constant below the things coming in, the first term is so-called positive of 20 logarithmic. Okay, that's what your quiz is calling actually. The second terminology will be minus 20 because the minus is happened because it's a denominator. Okay, that become, if you say 20 logarithmic, the top one is, if I take the entire amplitude ratio formula, K with that is multiplication, obviously 20 logarithmic K. So it is positive. Then when you say division, yes, it is called minus. Okay. Then denominator, whatever coming, you get minus 20 logarithmic of that. Okay. Of course, square root of 2, so it will be coming to the front, so 20 divided by 2, that becomes 10. Okay. So, but if it is minus means because of the denominator. But the top numerator whatever k value or omega value is coming is good. You have like 20 logarithmic base scale is coming out actually. So it is positive. You can refer the examples like this way.
So,
So-
the 10 minus 10 is how you take?
Minus 10
Is going to
formula?
up.
is that because of the denominator. Yeah, so
The
that's
10
like a
is
formula.
Oh,
Because we should look on our formula itself, k1 square root of. So it's basically is already division. So if it's division, when you come to logarithmic, it is minus. So that your question why the 10 instead of 20 why become 10?
Ah,
Have need?
yes.
Okay, that's why better write down because I'm telling that one only. Okay, maybe basically I can say 20 logarithmic of 10k minus, you know, right? So then 20 logarithmic 1 plus omega square
T square.
t square. So here 1 by 2, right? Actually it's a square root, okay? So the square root, well, when you take a logarithmic, it may not be on the power. It should be here. Okay, so then you are going to cancel. So that become 10. 10 logarithmic 1 plus omega square t square. Okay, so here will be the same thing. Just say like 20 logarithmic. Okay. So the first term, which is on the numerator, as per the question, obviously it's going to be plus. Okay, denominator come in, or it's always a negative will be there. So when you take a logarithmic of square root, it will be coming down, then it's cancelled. Okay, so that's how it works. Questions? Good. Okay, so you can refer based on this from our last session slide. You can compare here. Even now, this is one of the examples which is saying that that's our transfer function, which is written. Okay, 1, which is nothing but our gain constant is 1. So 20 logarithmic k minus 10, so it is all coming over here. When k equal to 1, t equal to 1, logarithmic of 1 becomes 0. Okay, as per you can check on the calculator. Logarithmic of 1 is 0, so end of the term everything is going to be 0 over here. Then here again the same thing. Then we have the rest of the terms. We can compare with the another example where 10 d plus 1. So it is under numerator. No no division over here. When there is no division, you can see it is become plus. Okay, so it is plus over here. So even though it's 20 logarithmic k, then rest of the things will be coming. So but instead of minus, it is going to be plus.
What is K?
What's that? Omega. No,
K. What is K?
k is a gain constant.
In the equation.
This one,
The equation. What is the K?
k is the gain
Just
constant.
10d plus 1, right?
And this one, right?
The top one. The transfer function.
Uh-huh.
K is 10d plus 1.
Oh, k equal to 10t plus 1. That is your transfer function. So what is k? Basically, we need to see that there is a 1 actually. 10. 10 is your k value. Okay, 10d plus 1, right?
Yeah.
You don't have your other things, so your maybe I can put it this way: multiply 10d plus 10. Okay, then if you put 10, logarithmic of 10 is 1. So you can try on a calculator. So your k value is 10. That's why it become like that. Okay, then we can substitute other things. Maybe you can look on other. Okay, maybe here. At least quite easier. So top one you already know is k is 3. Okay, for this case. So 3 substitute, then it's not calculated the numerical value. At least you know it's substituted over here. And let me see. Here, yes, k equal to 1. So k equal to 1. Okay, so you can refer your class 4C slide for this quiz. Let me go back. So for the reference where we come out on this quiz, so it is saying class 20, based on the numerator. Okay, so s 2s plus 1. So and then there's a denominator is there, but the first thing they ask is what is on the numerator. So it starts with plus 20, then it will going further onwards. Okay. So here again, okay, all the constant values is given. So just substitute on this transfer function, then you will get something like a transfer function. Based on that, you can calculate the value where the starting point. Okay, it means like the first number on it. Okay, so whether it is as per this value is almost like 13, somewhere 20. It starts like a 13 over here. Okay, somewhere here. Okay. So this one we need to calculate, and probably you can use to make the MATLAB. So easy to calculate. Instead of manually calculate, you just key in itself, it will tell you where it started. Okay. So it's nothing but board plot. That's it. So it will automatically make a curve, then you see where the curve started. You can really see from our last slides, last class session side. Okay, very simple. Even the things will be loading. Okay. So it starts from 0, right? From this curve, and this one is 20. So based on the transfer function, you know where the curve starts. Just board, it automatically generates the two graphs. Okay. So what you see, this is start from 20, and the previous one is start from 0. Okay, this is start around roughly will be around 10. I mean, I don't need to be very accurate, as long as I see from the graph, know what is the number is going to be. But of course, you need to use to make board plot. I mean, manually you can calculate, but it is faster when you use a board plot. Okay, so here you start from 0. So this one, this question start from 40. Okay, so based on your transfer function, the plot will be different. From there, it is just say where the starting point. Okay, so starting point, roughly look the numbers, then you know what is the answer going to be. Okay, are we good? Question from this? Because this one say like where is the starting point. Okay, so but of course all these numbers you need to substitute over here to get your transfer function first. Okay, why not? Maybe you can start something like pick one, do it now. At least we can try out what's going to be things. This one is already done. Okay, just give me a transfer function equation by substituting all the k, b, c, d, all the numbers you substitute. You know what will be. You want to zoom? I will zoom it. I think yeah, it's fine. Okay, is 9s. Okay, maybe you are not going to do anything much, so I can put it first is 9s, right? So just leave it as it is. A is, what's A? 6s, B
10.
10.
Yeah.
Okay,
So by 9s plus
9s plus
2.
2. Okay. So you can directly key in. You need to simplify things because MATLAB can do everything. Okay, so as long as you can key in things, maybe you can able to key in on your MATLAB, then automatically the graph comes in. Okay. So based on this, quite simple to make the graph. From there, we know what is our starting value. Okay, instead of manual calculation. Okay, so this is from our very first victory quiz. Okay, so kind of mechanical system. Then you need to get the formula. Okay, for this is like a spring, stiffness, and displacement. Okay, so the things, but the one we already learned from our experience. Read the question very clearly. Sometimes it say like it's not the system equation. I believe sometimes we overlook because that's a twist over there. So read the question very clearly, then select accordingly. Okay, sometimes almost similar, almost close, then you click wrongly, then 2 marks gone also for this. Okay, so anyway you can refer your slides and your past experience. Then okay, again so-called rotational system, we have equation of the system, equation of the transfer functions. Okay, so there is a various equation is provided, so you can choose the things, then it will be marked accordingly. Okay, so refer your formula sheet, refer your workouts, class notes, then pick it. Formula sheet is good enough actually for this case. Then again here the same thing, gain constant. So you can substitute all the values which is provided over here onto this equation, then something like this you'll get it. From there we can calculate what is your gain constant. Okay. D and D. Okay.
刚才说过吗？
Okay, so here's some detailed workout which is for gain constant. Okay, so like
也是刚刚才的。
the previous question. So what we can see, only the transfer function is slightly different. So what we see, you can refer, all the constant is provided. So substitute onto this function. So that's our equation. We substitute all the values which is provided on top. These values will be changing whenever even you log in second time. Okay, because like various numbers is provided, so automatically it fixes. So once you substitute, then obviously you can know it should be 1. So we're going to divide the entire equation, numerator as well as denominator, with that number. Then we divide it and we calculate it. So whatever on the numerator, that is we call as our gain constant. Okay, so we just need to type this number onto the calculator, then that's it. Try to be round up until like a 4 zeros, so should be okay. You don't need to be like very long also. Okay. Even 3 0 or 4 0 is good enough to get it, because it's still like plus or minus 5%. It'll still be good actually. Questions? Okay, so of course this is gain constant. Rise time, you can refer for first order system. The formula sheet also provided first order system, second order system. So that is our transfer function and the constants given. Substitute all the values and divide the values over here to the entire numerator as well as denominator. You will get your transfer function. Of course, K on top and T is at the below, which is 11 to the S. So time constant is there. To calculate the rise time, Okay, so substitute with the time constant, you will get it. What is your rise time? Once you calculate it, then substitute more to the pull up the time. So are we good? Or we have any question? Okay, great. I think I will move on because I believe this one from week 3 or week 5 we have it already. Settling times, similar things. Only the formula is different. So just substitute once you find your time constant, put it over there. Then we can calculate what is our settling time for this transformation. Then damping ratio. So damping ratio for this transfer function. So we need to, because what they given, of course this is supposed to be 1. So you divide the numerator and denominator, that will get it your transfer function. So from here, time constant 1, time constant 2. So you get the 2 numbers. Damping ratio formula is on our formula sheet also available. So you can just substitute T2 and T1, calculate, and you know roughly the numbers. Good, at least this one is select. Yeah. So you can able to pick. You don't need to really worry about number of decimals, because 0.2, 0.4, 0.8, 0.5. So kind of variation is there, quite easy to judge actually. And that's formulas, which is from topic 3. So we'll look on it and look the formula sheet, then select accordingly based on the transfer function. Second order system.
This is the one wrong.
Yeah.
This is
You
wrong.
haven't give much.
Okay, maybe I'll take it up. I haven't got the time to look on your things. First, I see everyone is 4. That's good. It's a good max on this week 9 quiz. Most of people 4. Okay, the average is increased. I can see the standard deviation. Wow, 5 already. Okay. But I'm expecting this quiz this Sunday. I want full max, 14 max. That's why I'm trying to explain over here. Okay. And it is the experience from week 3, 5, 7, 9. Until the 4 quiz, what you done, keep all those slides before you start this quiz. Okay, so it is going to be repeated. It is not new. Okay, but it covers entire thing. Okay, all the 4 quizzes, which is nothing but topic 1 to topic 5. It will cover everything. Yes.
The online exam, the result of it.
Midterm.
Yeah.
Not yet. Probably give me 2 weeks. It's a manual marking, so I need to do. I think after 2 days I will be free because today our last session. Then yeah, I can sit more on it actually.
Can everyone 20 can
Yeah, we'll see on it. But I believe everybody done a good job. So we'll work on it and validate it actually. But I was sure, even not only mid-semester, your current assignments also going to mark in July itself. So in a way, like by end of July, you already know out of 70 marks how much you are. Okay. The August is your final exam, 30 marks. So before going into exam, you know out of 70 how much you are. So you need to prepare more or less. So from there you know already. So because the cumulative out of 100, what is the passing? 40 or 50? 50. Okay. As long as you've done very good job on out of 70, so you don't need to really worry about on your exam. Okay. But maybe some people really not passing. They are really great. I want the grade actually. But to be simple enough to say all the batches, at least 10% people will be aiming for it, achieving also. I put it this way. Even people say like this subject is really very hard, but I put it this way: every semester and every attempt I look every year, at least 3 to 5 people more than 80 marks on this subject. Okay. So you count yourself whether you are 80 plus or not. So it's up to your effort and time. I put it this way.
Eric.
Okay.
Because I need to say already 70.
Can everyone can. So hopefully you'll try to break the
You want to take-
record.
You have to take
So
PhD,
far
right?
from what I
Yeah.
know, like 7 to 8
I wanna
years
give
on this subject.
Give me.
Try to break that record because usually 10%, 2 or 3 people things will be there. Maybe you guys can break it. I hope you can do it. Put effort on this module, okay? So I believe you have other subject also, but I think have a break on it. I mean, have time for it actually. So you can allocate it. Okay, so yes, good. We will work on it.
You want how are the exact calculation?
And yeah, this is about magnitude.
You done?
No, I haven't.
and
Yeah, so
send the
basically step
assessment?
input,
Chicken, I
step
haven't
output.
done lah.
Sorry. Step
Really?
input, ramp input, sign input. So we have transfer
few more days only.
function, put the numbers,
Yeah lah.
then we try to make it 1 over here. Then we know what is your gain constant. So gain constant with the amplitude, then you can say what is the magnitude on it. The thing H value is provided in the question itself. So we know your gain constant, H value is 6.5. You know what is the magnitude on it. Okay. You need to type on that, then you know your answer. Questions? Okay. Then, okay, so this is more towards topic 4, amplitude ratio, phase angle. Exactly your week 9 quiz. Okay, so actually I pulled out the same quiz over here. So I think we already explained, we already know it. Any particular question on this? So far, I hope now you can able to see your quiz result and where it went wrong or not. At least it's just like manual calculation, I believe. Sometimes errors will be there. Amplitude without multiplying, without dividing the H value.
Oh, that's all.
That's it.
One
It's on the slide. You specify what is amplitude ratio. That's only divided by H or not.
Please Last quiz, how many questions?
This one?
Ah,
This one 10 questions.
You come late then us.
10 question, 1.5 hours. I think really a
14
good time.
question for you.
I put it this way. So roughly you can take 5 to 10 minutes for one question. But some is MCQ really, because like true or false and other things. So may takes lesser time. Okay. So some questions maybe you need to refer MATLAB or even calculation, manual calculation. But mostly, I put it this way, most people will complete 30 minutes or less. You won't be required 1.5 hours. So far, what I see in all the statics, less than 30 minutes completed.
1 hour complete now.
half an hour one question.
Maybe hour 20.
But it's given like 1.5 hours, but mostly I see because it's from repeated, from big 4 week quizzes, so you know what is the answer, you just identify it. Okay, some maybe numbers is different, but the pattern is similar, is quickly you can calculate it. Then you know your answer, what is going to be. So all the numerical numbers, I put it to say 5% error still acceptable. Okay. So maybe I put it this way, what is the 5% error on here? Instead of 16,
全部都和我一样。好像我的 question 多问题，你这两个字就不一样。字就不一样，你能玩。
16.6. Even it can be 15.8. Instead of 16.6, I can even type 15.8. Still consider okay. Still consider it will award marks. Okay, that is the error. Like 5% is already there. You have a number instead of 16, it can be 15. So you still get marks. Okay. Likewise, you can also say 17.5. So from 15 to 17, still you get marks. Okay. So it is not really very tight numbers. As long as roughly you know your numbers, you will get marks already.
结果你看我大概算一下。
So this amplitude ratio, which is already we know it, and phase angle,
这个是多少？
and this is again
所以得
phase
拿完
shift.
20乘
Yeah, that's
4
why we did on our last session. I tried to pull out the last session slides. Hope it was helpful when you work out. Okay, so that is the one of the question or two questions will be true or false. Okay, but read the question very carefully. Say like, what is the question? Is it is or not? Is anything is there? Consider that when you click
是
true
谁
or
还不
false.
够诶？
Because only one attempt.
啊？
Here again, damping ratio, time
go back,
constant,
谁？
and imaginary pattern.
Can go back. Previous question can view, right?
Yes.
Like previous question we can view in the test.
Yeah, it will show all the 10 questions. So below only you can see submit button.
Mm.
So I mean all the 10 questions, you only click, then you can go up and down, then you can change your choices. Then finally once you submit, only submit. So it is not going by every question like other quizzes. Actually. This one is one shot.
Okay.
Once you open, you can see all the 10
还
questions.
不能呢？
So
啊？
maybe I put it this way: if you do it as quickly as possible. Once you're done and you maybe let's say 30 minutes or 45 minutes, then don't submit it.
20多。
Relook all the answers again. Because first time when you do it, maybe you on the urge to finish up because you are expecting whether time is enough or not kind of thing. Once you fully complete, don't click submit. Go again one more time and relook all the answers. Then take until more than 1 hour cross, then submit. I mean better reserve your time. I know you guys are busy. Don't submit. Okay, so once you complete, just relook all the answers what you selected, because 1.5 hours time is there. You can see the time clock over there. Okay, until you make sure everything is right, or you can change your options or change your numbers. Particular question then click
出
submit.
来就快了。
Okay, so at least it will be
我还没有看呢。
sometime able to
Okay.
correct. Sometimes you know what is the answer, but maybe you may click wrongly another option. Okay, so it
Yeah.
happens because we are in the rush. So obviously we on the first phase when you look, it's always we need to look the time. So we try to complete all the questions. Sometimes it's very easy to click wrongly.
所以
Okay, so you know what is the answer, but you click wrongly on it. So take your time. I'm expecting average time more than 1 hour. It means like you might be completed 30 minutes itself, but just to
这
read.
个是我们是一起做的，哈，
Confirm all the answer is correct.
这个
And
题
if you really confirm, yes, okay, go ahead and
我们一
submit.
起做的，哈，
Okay, but it won't take 1.5 hours. I'm very sure of it. Okay.
这个错了。
That is my feedback, and I'm expecting full marks from everyone from this quiz. Okay, because the quiz is very simple
这个是错。
compared to your assignment. Assignment you need to do a lot of works. Okay, whereas the quiz, let's say 1 hour or 30 minutes, is just it. You will already got the marks. So 14 marks. Try not to lose even 1 mark on your exam.
没错。
Okay, and that's about our week 11 quiz. I will share this slide tomorrow. Then it's on the same Google Drive. So hope everyone can able to access the Google Drive, and you can able to refer
有
it.
4点半。
And of course, you can keep reference your past week slides. So all these things keep it
6分还给你4
open
点半。
before you start the quiz. Okay, and make sure your MATLAB is on. Okay, because couple of questions you might require to use the
哎
MATLAB.
没没。
Don't go and log in at that time. Okay, make sure log in, open, and you can run your previous example, see whether the graph is coming or not. Everything
明
make
天
sure
我
is
们
there
discuss。
before you start the quiz. Yeah, question? Sorry. So everything make sure working, then start the quiz. Okay, and make sure nobody disturbing you. Okay, of course, don't disturb me also. I mean, kidding. Of course, if you have a question, please WhatsApp.
That's it.
Okay, so I try to catch you and try, even though you sometimes type wrongly, WhatsApp me. Even click when you found something like something wrong, just WhatsApp me. Take a photo, then WhatsApp me. I'll go and check it out. I hope I have full support so far.
Yeah.
Yes.
Okay, good. And this one I'm expecting more than 10 marks out of 14.
14 max.
Yeah, 14 is a max of course. So even if I mean I say like week,
Even now it's
you
like-
know the pattern I know, but I believe like now week 9 quiz is more than the average is increased. 4 marks maximum marks most of it got. Some we got like 2. The lowest is 2, but mostly all 4. Okay, so overall increase.
The example, the working.
Yeah. Oh, you mean this one?
Yeah.
That's not the US one, the last quiz.
Yeah.
It's like minimum 2.
This one also given, right? Later.
Yeah, this one is already given, even some is typed already. So like it's already there. So you can say what is the ways to do it. Of course, if any mistakes, let me know because I believe it's all corrected, all checked. Okay, so that is about our week 11 quiz. That is
那个 assignment 有没有？
over here. Okay, so that is your week 11 quiz. It's already open. Today, yeah, today morning was open. Yes, quiz. Your questions.
Assignment wise.
The next one I'm going to talk about last time.
Wait,
Yeah, I know the crunching questions on the last session. So I'm trying to be focused on that.
PSD haven't started. This one isn't coming.
So are we
Next
good
one.
on this is actually a student view,
R&D.
like what you are exactly living. I was
Hey, aren't
make
you
it that
3
view.
assignment, right?
yes.
So it's 90
Last one
minutes,
presentation.
10 questions.
Ah, last one presentation.
Okay, so here the things.
So means that
All the
first
questions
one.
released at
No,
the
no,
same
no.
time.
Total 4.
So but the moment
Presentation
once you
including
start
4.
all the 10
Presentation
questions,
including 4.
okay. So you just select it, then submit.
Sure, you will.
Of course, it is a multiple. I mean, from the question bank, every time when you log in, the question itself change, even everyone. Okay, good. Are we good on week 11? No more further questions. Okay, I'll close it. Then,
这个只是
yeah, so that is our upcoming.
第二个就是放
Okay, so assignment wise, I already opened just now, so it means like you can able to view. Okay, so first thing to tell you, it is not like our previous assignment, like mid semester, like you have a time limit of 4 hours. Okay, but these two assignment, I don't have any time limit. Okay, so no time limit. So it's open today already. So until 15 July. So you have like the next 2 weeks time. Okay. So you can able to download. Okay, that's where you can see like there's information and what you can see there's a PDF file.
TNC
Okay. The PDF file contains 4 questions. Okay, maybe I'll open it. I think I don't know whether I open already.
这个两个那个它还有两个
Okay, so that's the question paper and.
我 TNC 还没有 release
So overall, first assignment 1, you have 4 questions. One is mechanical rotational system, and your block diagram reduction from topic 2. This is about topic 1. This is about your topic 2 reduction techniques, and this is about topic 3, and this is our topic 4 bot plot. So every chapter, 1 question is there. Okay. So typically, I can say each question 5 marks, or maybe 2 marks, 2.5 marks, because it's 10 marks for this assignment. Then MATLAB is another one. Based on assignment is 10 marks. MATLAB is 10 marks. Okay. So if you look on MATLAB also open on today until 15 July. If yours done already, you can submit earlier. Okay. So it's up to.
Today just open only.
It's
can
up to
submit.
individual, so whether it depends on your own schedule, and I can expect. I don't think you might require more time on it. It also depends on other modules, what you have workload and
A lot.
A lot, yeah.
Yeah.
But maybe I will give very open, never like no restriction. Okay, but the no restriction doesn't mean like everybody come on 15 July. Okay, better try to be earlier. But what is your deadline for other modules?
Have next
First week?
This week have one.
Mhm.
Then 26, I think. 26 one.
End of July.
Yeah.
Or then you have. I mean, I'm on the
Middle, yeah.
So
So
you
the-
don't need to be end. You don't need to be at the front. So good.
The whole month doing assignment.
Yes.
Oh, no classes. So you don't need to come.
No, have a classes.
Oh, have class.
from the
Oh, Henny is
yeah.
coming.
Yeah.
Okay, correct.
Have a
The
classes.
university lecturer will come.
Yeah, but Go one is online,
Rapid
right?
fire, right? Kind of.
Online class,
Online.
right?
Or
3 days straight.
3 days.
Go one is online.
Online then is the IME.
Okay.
Academia.
Oh, I mean,
Online will
oh,
be very less.
one day only, right?
1 day.
1 day.
Saturday.
But it's all like a rapid fire.
Yeah.
Yeah.
Every semester.
Even Henny itself will talk itself.
I think it's
Okay.
more crash
Okay.
Crash course.
Yeah.
But
But
attend that.
yeah, that is what the standard they say. Like the university lecturer also need to tell the same topic, maybe different perspectives. I believe you may get some more information, which is I've not shared. So probably more exercise, more examples.
Just give us the question.
Release the
Then the
question
next thing
first,
will give us the answer.
No, only answer. Just give me the steps.
Oh, ChatGPT can do. Once you scan it, so you tell you what is the answer. So you need the question only.
ChatGPT can't do this.
Okay, I mean technology is rising. Okay, I know everybody know ChatGPT 4.0. 4.0.
Oh,
Why
yeah.
not?
So
Expensive.
that even
But need to pay,
next
yeah.
level. But of course need to pay for it. The normal one,
Then
yes, you don't need to pay.
Santos using.
Give me money.
Expose.
Give me money.
Expose.
Okay. Question. I mean, I'm telling you, even though this is one of the common thing I'm facing, usually I've been more generous to open up, and there's no time limit for these 2 assignments. Okay. What will happen? Somebody will do it. Everybody will copy it. Because somebody make mistake, everybody is mistake. So, good and bad, I put it this way, whoever did and whoever you are taking as a reference, don't exactly copy paste. Try to find something mistake over there. Then you get more marks. Otherwise, you will get the same marks. Okay? So, even your friend is so generous, sharing your answer, supposed not to tell all this thing, but I'm telling you because everyone keep copy paste. I kept still, okay, very simple. no typewriting. I'm strictly no typewriting for this assignment
What?
because no typing.
Oh.
Typing,
Word,
right.
Oh, right,
document,
right,
Excel
yeah.
document,
Yeah lah.
PowerPoint,
Is it-
no.
You want to type
You type yourself.
You want to type
Yeah, that is the reason for it why I'm saying no typing. If somebody had to die to type everything,
No.
copy paste, even change the font, a style, a color, then another one submit.
Chantos.
No me lah, you. You are the
Submit.
one.
You sorry?
If you submit already, then you check something wrong. You have you submit again?
No. One time submission.
Message
Oh.
him.
Oh, see,
Yes,
another
yes,
loop
yes.
is coming.
Oh, this is one time submission.
Yes,
Oh,
one time
okay.
submission. You have 15 July, but it's allowed one time submission. Unless you are any specific reason, like okay, you can send separate email or WhatsApp separately with a good reason. So you need to think about the reason as well, not just telling the document. Okay, so why I'm saying need to write, at least you know, even though you're copying, I know you are writing on your own. Sometime when you write, right, you will find the mistake on your own, okay? Because suppose not to like this way, there's something wrong. So at least when you write itself, you know if something wrong, you are copying it. At least there's a chance you might be able to look on this, okay? But if you say any graph or anything, you can use to make MATLAB, also called Excel or even other things, extract and paste on your report itself. Those things I don't expect to draw it, but those graphs you can get the image. That's not an issue. But most of the answers handwritten. Okay. Then you know when you're copying itself, you know where you are making mistakes. When you write itself, suppose not to be like this, then you are asking your friend, is it correct or not? So at least you know some kind of work will be there. Okay. Take your time. You have like 2 weeks solid time on it for this this assignment. Okay, so this is again when I open probably 3 questions. Okay, so from MATLAB, you are going to use the MATLAB software. Okay, and okay, let me open. Yeah, 3 questions, 9 marks. Okay, maybe don't worry about this one over here. It's 10 actually. Okay, so this is okay. Maybe I'll try to give some mimic on this things because simulation link we never tried. So I try to explore after the break. Okay, so MATLAB simulation link is a button over on top. So you can able to pull out and you can able to make it. So I try to
So this one
explore.
we no need to handwrite, right? This one just copy.
Yeah, even if some is really MATLAB, then you cannot do anything. Yes, you can able to extract or snip the entire thing, then put on your assignment. Yeah, justify your work, it's okay, but rest of thing you can.
So this one we need to take a snap only.
Yeah.
No need to get the file, save the file, then you need to send it to you.
Yeah, actually you can able to submit only one file only.
Oh, okay.
Maybe PDF file or Word file. So probably you download your MATLAB file. I don't think you're able to attach. Okay, so yeah, it's a good question. Maybe you can try. I don't know whether 2 file can able to enclose on it. Usually they allow 1 file only. Choose a file, then click, then only 1 file, then submit directly. So it doesn't even have a second file on it. Okay, so maybe I will go through this simulation link maybe after the break. Okay. Let me go through it. Okay, so this is first question, and there's a second question more towards MATLAB questions. We can refer our MATLAB things, and third question which is multiple division using MATLAB. Okay. So overall, if you ask me, here is 4 questions and here is 3 questions. So 4 questions from assignment and 3 questions from MATLAB. So overall 7 questions. We have 2 weeks time until 15 July. Okay, so just work together, then complete it, then submit it. Okay, good. Any clarification? Okay, great. Maybe we'll work on it, and it's already open. Yes. Yeah, you can see student view. Yeah, you can able to see file submit. Once I start, maybe I see whether I can start. Yeah, okay. Okay, so there's multiple locations. Oh yeah, you can.
Add another file. Oh.
So
People hold.
yeah, you can able to do that.
Can.
Okay, in the case, put it this way, get the MATLAB file. Okay, so you know how to save the MATLAB file, right? Once you save,
Screenshot.
okay, I will demo it. Okay, so
Screenshot.
screenshot, yes, of course, you need for your assignment in the Word file, you need to put it actually. Downloading is mlx.m file, so you just download in your MATLAB drive, or you just click on it, download to your local computer. Okay, then yes, you can able to enclose, or you can directly from Google Drive, OneDrive, Office, Studio. Okay, Studio actually no need. I'll upload is good enough from your computer. Okay, so you can able to upload. Then you submit. Cover sheet. Okay, doesn't matter. So it's good. So download, especially for MATLAB report, you will, because the other one no need actually, because this assignment is totally manual. Okay, whereas the MATLAB assignment only you are going to do it, so you can have multiple files.
Manage the report.
Can put zip file.
Okay,
Zip.
yeah, you can zip, PDF, doc, all can. So it because it's just a file only.
Assignment is use handwriting.
Yes, assignment handwriting.
Lab is report PDF.
PDF plus MATLAB file. Two files will be there.
Okay.
Okay, so that is the three things will be what we are going to look on from now until like 15th July. So this is going to be end on this Saturday. This is most on 2 weeks. We have like 15th July. Okay, so good. Let me close down this.
Okay. Okay,
Okay, great. Let me close down everything. Otherwise, many things will be open. Will be. Let's see. Okay, so maybe let me see. This 4A. Okay, so I remember last time one of the question is asked, because we are topic 4 always looking like there's a sine curve or any curvature, I don't know where they're going to use it. So today we'll be exploring on it actually. Because we say sine curve, step input, ramp input, or you can say bot plot, or you can say polar plot, all have a curve, all have signals. What I'm going to do with this. So let's explore. The most important on this automatic control. Okay, regardless of the controller type, all nothing else signal. Okay, so that is the overall thing what we are going to see. In the industry, I believe you are working with the machines, even it's kind of automation machine or standard machines or legacy machines or robots, all they call PID controller. Hope you heard about the PID name. PID controller. Okay, that's what the main part of this controller type, one of the types. It's not the main thing, but of course, more generously, all they are using PID controller. Okay, let's explore. Of course, we from the very first session, we already know the kind of input to the system that it will produce output. Let's say electrical fan. You supply the AC power to the fan will rotate, you will get the airflow. It's very simple application. So then when the system is going to be, this is like open loop system, and when you want to be a closed loop, obviously there's a measurement device, so we can have one more sensor to give and make the system to work what you desired. Okay, so what actually you want, then it will work. That's simple like our air conditioner. You set 20 degrees centigrade, even the room is not 20 degree, the aircon is on. And there is a thermostat which is measuring the temperature every second. Then it will feed back until it reaches 20 degrees. Then you cut off the aircon power. Okay, it's momentary. By the moment keep opening door the close, then obviously temperature rise. The aircon is on automatically. It's based on the thermostat measuring the temperature. Okay, either open loop system or closed loop system. Okay, so it will be work based on the type of controllers what we are trying to do. In a market, okay, there is a called as two position or because on-off controller. Okay, that's one of the common, very inexpensive controller. Most of the locations we are using it. Then we have P controller, also called proportionate controller, integral controller, or you can say proportionate and integral, called PI controller, or PD controller, or PID controller. Okay, so these are the basic controllers which is widely used on all the applications. Okay, when it is very sensitive or more accurate you need, then they probably go this sixth one, which is PID. Okay, and robotics, all kind of robotics, they go for PID. Automation, machine design, customized machine design, assembly machines all go for PID. Okay, and especially semicon, precision industries, all pick and place equipments, all PID only. Okay, even though the motor is running, servo motor, stepper motor is running by PID. When you talk about a motor which is running by AC induction motor, conveyors, conveyor belt, all using on-off control. I mean like two position control, either on or two position. Why? Because that kind of motor you cannot able to get accurately to the position. So there will be a tolerance. Let's say 1 mm tolerance or 2 mm tolerance. But as a conveyor, when it's moving, it doesn't really require to be stopped very accurately. Okay, so those kind of systems, then they go for two position control. It's very simple. In an airport, the bag is coming on the conveyor. Okay, then when they cut off, even the bag moves likely halfway or even further, it doesn't make any sense. So it even acceptable. So in that applications, I don't need like a PID. So I just go for two position control. It purely depends on how much accurate you want. If it's really precision you need, then you can go for PID. Otherwise, this is going to be most common. Okay, so it's very simple to see. You need a very accurate or average, or it can be acceptable tolerance. Then you can choose the most expensive controller type or a cheaper controller type. Even two position, I can simply to say the light on off switch is two position, either off or on. Only two position, right? When you switch on, yes, power is on, the light is on. When you off it, cut off the power. So two position. Okay, that is we can say depends on the system. If the system is not complicated or not required to be more precise, I don't need a PID. The rest all requires, we can go with an average. Okay, these are some of the industrial controllers, industrial systems widely used actually.
In this video, we're going to talk about the PID controller and it.
Okay, so now just closely watch this video, which is talk about like PID and the curvature, because I believe every calculator there's a rise time, settling time, and offset timing and everything using a formula. What it means. So we will be watching on this video, then I'll explain about it. Of course, we know the formula to calculate. Then now we talk about this.
Transformation from a single station device to what it has evolved into today. We're going to explain why PID controllers are used in industrial processes instead of simple on-off controllers. We'll illustrate how controller settings called proportional, integral, and derivative affect different processes under control. We'll also provide an overview of the very important activity called controller tuning. Let's start with a discussion about home temperature control, as it's familiar to lots of people. This house has a furnace that distributes heat throughout, and a wall-mounted controller called a thermostat. The thermostat has a sensor that measures the house temperature and compares that measurement to an adjustable set point. If the room temperature is below the set point, the furnace is turned on. When the room temperature increases above the set point, the furnace turns off. This type of control is referred to as on-off or bang-bang control. Here's a plot of what the room temperature does over a period of time as the furnace turns on and off. As you can see, the temperature is not exactly held at the set point of 70 degrees Fahrenheit, but cycles above and below the set point. On-off control may be okay for your house, but it is not okay for industrial processes or motion control. Let's look at an example of tank level control to explain why. The valve fills the tank as the pump drains it. If the valve is operated with on-off control, the water will fluctuate around the 50% set point. For our purpose, let's say the fluctuation is plus or minus 10%. In most industrial applications, this fluctuation around the set point is not acceptable. Okay, well, what if it's possible to throttle the valve and place it in any position between on and off? Now we can move on to talking about a PID controller. P stands for proportional, I stands for integral, and D stands for derivative. Because every process responds differently, the PID controller determines how much and how quickly correction is applied by using varying amounts of proportional, integral, and derivative action. Each block contributes a unique signal that is added together to create the controller output signal. Let's look at how a PID controller fits into a feedback control loop. The controller is responsible for ensuring that the process remains as close to the desired value as possible, regardless of various disruptions. The controller compares the transmitter process variable, or PV signal, and the set point. Based on that comparison, the controller produces an output signal to operate the final control element. This PID controller output is capable of operating the final control element over its entire 100% range. Most modern PID controllers are part of a PLC or DCS and are created in the program control logic using block commands. Before PLCs came along, a PID controller was a standalone device responsible for controlling one loop. A control room would have dozens or hundreds of standalone controllers mounted on a panel. There are still many standalone PID controllers being manufactured and used today. Okay, let's get back and talk about what each of the P, I, and D components of the PID controller does. Remember earlier we said that the PID controller is responsible for ensuring that the process remains as close to the set point as possible, regardless of various disruptions. Let's refer to the difference between the process variable and the set point as the error signal. The proportional block creates an output signal proportional to the magnitude of the error signal. Unfortunately, the closer you get to the set point, the less it pushes. Eventually, the process just runs continuously close to the set point, but not quite there. That's when integral jumps in. The integral block creates an output proportional to the duration and magnitude of the error signal. The longer the error and the greater the amount, the larger the integral output. As long as an error exists, integral action will continue. The derivative block creates an output signal proportional to the rate of change of the error signal. The faster the error changes, the larger the derivative output. Derivative control looks ahead to see what the error will be in the future and contributes to the controller output accordingly. That brings us to a term called controller tuning. We said earlier that every process responds differently and that the PID controller determines how much and how quickly correction is applied by adjusting proportional, integral, and derivative action. Controller tuning involves correctly setting the controller P, I, and D values for specific process requirements. Interestingly, the correct settings achieved by controller tuning can differ vastly between processes because of specific requirements. For example, after the controller has been tuned, a set point bump of 1% in a tank level control produces a quarter wave damped response. This type of response may be suitable in a tank level process, but could be disastrous in a motion control process. There are many different manual methods for tuning a controller that involves observing the process response after inflicting controller set point changes. One method involves increasing the amount of set point change and repeating the procedure until the process enters a state of steady state oscillation. This method of tuning produces adequate results, but is often impractical in many applications. For example, how practical is it to force the fluid level in a large tank to reach a steady state oscillation? Most process controllers, PLC, and DCS loop controllers sold today have auto-tuning capability. The PID controller learns how the process responds to a change in set point and suggested PID settings. Regardless of whether the initial PID parameters are derived from the manual or auto-tuning methods, additional tweaking is often required by seasoned automation professionals to get the response desired.
Okay, so first thing first, this one trying to introduce where the PID controller or anything will come in. Okay, so the very basic, it is manual to key in the P, I, and D values. Okay, and like iteration. There is no specific standards you can able to see, but there is a recommendation will be there when you connect it. Okay. Even there is a software which can able to click, it automatically sends every signal, then automatically propose the values of PID. Okay, but both the method is widely used in the industry. Even if you look your software engineer in your company or motion control engineer, they keep just changing this number and keep trying and make the motor move front back kind of thing. Okay. By moving, you should not produce any sound. But if you're changing this K, like PID values, then the motor move itself, make the move itself, you get a sound on it. So they know the value is wrong. So they keep changing. This is purely manual method, manual ways to do it actually. Okay, and it depends on the brand of the motor, model, make, and where they manufacture, and how the load condition and various parameters is involved. It's not only motor manufacturing, almost the assembly also called the mechanism and the load it carries it. Okay, so all it makes it, but in general, auto tuning is widely accepted because now the software is more intelligent to iterate what we do manually. Then it gives the option. Then let it try with that option. Mostly it will work. Okay. That is most of the things what they're doing. So where you start like set point things, let's say whatever your values and your set values. So that's where it comes in. No matter whether you have a PLC controller or microcontroller or PC controller. Usually all the industrial automation controllers is only these three classification only. Even if you want to be a microcontroller programmer, it's only three types only. One is using generally they call microcontroller. Anybody play on Raspberry Pi, Arduino, Microbit? Those are very small board, very cheap, like less than $50. It can do it. Okay, so that's microcontrollers. Okay, then the next phase in very big machines, then they call PLC, programmable logic controller. So that is another level. It can be connect many lights or many motors. You can able to connect on it. Simply to say 16 input, 16 output, or 32 input, 32 output. It's something like 16 bulbs I can connect, or 16 motor I can connect in one slot itself. So and you can, it's expandable. So you can keep on expanding. Even this entire building, no matter 10-story, it can able to connect all the lights over there. Then they can able to on and off from that desk itself. They don't need to come over here. Don't need to come and off the switch over here. As long as they see the intensity also there, mean like light is on, then they can off from their laptop. It means like 16 lights can be off one click itself. Also it can be expandable based on the number of input, number of output. In general, PLC is most common controllers using our industry. Okay. The next level is so-called PC control. PC means like a computer programming using C++ or Python programming. Then you can do the same thing. Okay?
everything.
It becomes more complex because you need to have coding, hardcore coding to write on it. Okay, so versus the microcontroller and PLC controller is very easy. Even 1 week learning itself, you can able to do the PLC programming. That's very simple. Okay, the same most of the industries they're trying to adapt PLC program. So it's very easy to learn on it. You just search on YouTube or Google PLC program. So it's like a ladder diagram coming. There's a 5 types in there. Most general out of 5 types in PLC, ladder diagram is most famous in entire Singapore. No matter which country, which company it is, all they're using it ladder diagram. Okay, so it's like a ladder thing only. No coding is required. That ladder diagram behind the software it will convert as a coding. As a human, I don't need to learn about the coding, but I just need to connect a ladder with the just pull out then connect the line. That's it. Okay, that's why it's widely practiced. Even is a very good salary can call as PLC programmer. Okay, that is the second level of controllers which is widely acceptable, widely used on industrial machines. Okay. So now, when you ask about this is the on-off controller. Let's say now, on and off manually can do it, but if I say that is on and off, there's kind of fluctuation is happening based on the controller. It's just like a water filling on the tank. You just need to on the pump or need to on or off accordingly to maintain the water level, okay, or the chemical level in the tank. So by means, if you are using, so that is the range, let's say 20%, maybe it is good for home but not for industries. So they try to adapt, instead of on-off controller, we go with PID controller. Okay, so it means like we need to be on and off very accurately and trying to maintain the set point. Okay, of course it depends on the industry type as well. Okay, so it depends on how much accuracy is acceptable. Let's say 20%, 1% or 0.1%. So it is all matters of the accuracy you are looking for. Okay, the controller type will change accordingly. The most common is PID. Okay, so this one we already know from our earlier sessions. We have a lot of blocks and feedback and everything. Out of this, there will be one new block is there, which is so-called constant. Even we can calculate it like gain constant, K value. It's nothing but one of the constant multiply the equation. Okay, likewise, here after you get something, this signal what you are getting is going to be manipulated or multiplied by this block before going to the actual machine. So this is automatically changed based on what we are getting in actually. So the signals, let's say now on and off is like a very big sine curve where we can adjust this 3 constant. It will be like a try to maintain the same level, let's say 50 mark on it actually. How fast you can able to get to that level. So based on P, I and D values, you can able to change it actually. That's what here is trying to reflect, manual or automatic. Here one of the application which is say like in your home, temperature controller. Of course not over here, like Canada or US, they have like thermostat, like an aircon, they have an opposite like heater. Okay, when you say heater, how to on and off the heater to maintain the same temperature to the entire house. Okay, it depends on the controllers what they are having it and that operate the furnace. Okay, accordingly. Okay, so that's what here the thing is very clearly specified. When I said 70 degree Fahrenheit, as I say on and off switches, controller type, it is, you can see kind of waviness. It is not exactly 70 degree, but there's a plus or minus tolerance will be there. Okay, it might be okay for home. Okay, because it is not going to be so accurate. As long as error is there, still you try to maintain. It goes like 75, then you get like 65, 75, 65. Even it is not 70 degrees, still is okay over in the home applications. Whereas it comes to industries, maybe not actually, because it will affect the secondary downstream process, everything, and the quality will get affected, the end product. So for industries, maybe not. So we cannot able to use on-off controller on this case. So we need to jump into PID controller. Okay, so question, anything very familiar, because this is where it comes in. This is what we are calculated the settling time, rising time, and everything using formulas for the first order system and second order system. Okay, so questions at this moment, because this is the point I want to stop it actually. Because initially we do calculation, and last session you asked where I'm going to use it. I don't know where I'm going to use it, this curve. So what is the settling time? Settling time is very simple to say. Now, regardless of the tolerance, from the thing it's coming in, how long the time requires to come in. Let's say 10 seconds or maybe 10 minutes. So what is the time? Okay, so that is, we can able to calculate manually, but that reflects the efficiency of the things. It's even very simple to narrate. When you on the aircon in your room, okay, then probably you put power mode. So after maybe 5 minutes, let's say your room, common room, then it will immediately come back to normal, because the 5 minutes is good enough to chill down the current temperature to maybe say 18 degrees centigrade. It immediately flash down because the room is small size, then it's cut off to normal mode. So it depends on the volume of the room, then the power mode even trying to cool down the things. That is the time duration. Okay, so let's say a minute or 5 minutes or 10 minutes. So to chill down the temperature, we just set like 18 degrees centigrade. Currently probably we have like 25 degrees centigrade. By having that 5 minutes itself, it drops of 25 to 18 degrees. So that is what you can say the timing which we need to calculate. Okay, so maybe for our room, even if you take 10 minutes, it doesn't really matter for me, but industry is needed, because the process will affect the quality of the end product. Okay, so how fast you are cooling and retain that temperature, not too much unstable on this. Let's say 20 degree or 18 degree, you should be there. It cannot be like drop again 25 then come back actually, because the product what you are going to put in, it may be not going to go actually. We try to maintain that. Okay, so that's why we see the curvatures are coming in actually, and that's why we calculated. Over here is trying to explain the tolerance level. Maybe it depends on the application whether it's acceptable or not acceptable. So this is what we can say as a PID. Question. So this is the most common. And when you tell to anyone, I studied automatic control, they surely ask, what is PID? Because if we say like, I don't know what is PID, then have you studied automatic control? That kind of next question will rise actually. Okay, because this is most popular to make it more efficient systems, to make it on, simply to say on and off more efficiently. Okay. It can be just on-off controller can do it, but I want more accurate, more precisely to manage it. Then this is get into picture. Okay, most of the robots need it, because it's very simple when the robot goes and smoothly turning, not out of sudden is moving actually. So if it is out of sudden is moving, whatever on one hand all spill out. Okay, normally a tray is coming over there with a lot of foods and everything. It has to move smoothly and move forward, then move smoothly. So as a human, very simple, even we pour the tray, when there's a tea cup with the full of tea, we will be carefully moving it. When the tea level is lesser, even you can move faster. So basically, we analyze and we move accordingly. So, but robots or machine doesn't know anything. So we make sure everything moves smoothly and comes up. So that is because of PID. Okay. Yeah, so that's about the system where the PID getting in new blocks onto the existing system. Regardless of the disruptions happening, based on the feedback, this one automatically calculate, adjust the number. It is not constant, it will be sensible and measure on automatic.
Master property.
So various things will be getting in
for property.
and based on the parameters. Okay, so here trying to explain about what is P, what is I and D. There's a slide is behind which is even have a tabular column on it. And yeah, that's kind of offset error values and things. Okay, so based on P is like a quickly respond and trying to get it, but it has a big rise on it actually. So the error is going to be more actually. Then I will be, rise will be lesser but takes longer time. Even T, even it is reduced a lot but takes a lot of times to come down. So it is not like sometimes like just P controller, I controller or D controller. So it can be a combined or it can be individual also. Okay, so purely depends on the type of application where you are using it. So it can be tank level controller. You can adjust your PID accordingly.
Which is only media.
Or it can be other type of controllers. Even tank level is considered okay based on the basic tuning of PID because it gives like a 1% error. 1% error may be for this application still acceptable. Whereas the home I can say 10%, 20% error. Whereas this simple adjustment get 1% error, like instead of 50 it can be 51 to things. And probably this is okay for, but maybe not okay for robot. 1% error is big cost on it. So that's why it depends on the application. Okay, how smoothly you want to control it and make it move accordingly. Okay, so they're trying to explain, and mostly nowadays come with the automatic one. Okay, so they have like automatically calculate and try iterate it. MATLAB can do PID auto tuning. Once you connect, MATLAB sends everything, then it will automatically recommend what is the PID value in it. Okay, so most of the software is now intelligent enough to explain what will be the PID in the system. Okay, so there is one more.
An on-off or bang-bang controller has only two output conditions and switches abruptly between these two conditions. In a PID controller, P stands for proportional, I stands for integral, and D stands for derivative. The PID controller is responsible for ensuring that the process remains as close to the desired value as possible, regardless of various disruptions. The PID controller determines how much and how quickly correction is applied by using varying amounts of P, I, and D action. The proportional block creates an output signal proportional to the magnitude of the error signal. The integral block creates an output proportional to the duration and magnitude of the error signal. The derivative block creates an output signal proportional to the rate of change of the error signal. Controller tuning involves correctly setting the controller P, I, and D values for specific process requirements, either manually or automatically.
Okay, so here is trying to explain about on-off controller and PID controller, where it is what is P and ID. Yeah, so first is talk about just a P only, P controller. P controller, of course, it is responding, but it gives offset value more actually. Okay, it takes higher accuracy differences. Okay, that is just a P controller. Whereas D controller, which is having a more duration, more magnitude, I mean like longer time it takes to do it actually. When you just use a I controller, or when you use just a D controller, it takes a longer time to settle down. It takes even more longer than I. Okay, that's why it is simply to say not purely using just P or I or D, or they try to combine with the combination of PID, then it will be much more better. Okay, so most of the common accuracy systems, all they are trying to use PID. Okay, so yeah, let me stop for a while, but let me. Okay, so when you talk about like industrial controller, on-off controller, or I can say proportionate is basically I can say a liquid filling on a tank where the float will closing the inlet pipe. It is when the float is more deeper, then the more water coming in. When you're getting in, almost getting filled, this float is going to close the wall very thin line of water is coming in. So the inlet is proportionately open and closed. Not same level of water is coming all the time when the water flush tank, which is a toilet flush, will happening. So even you open the top of the toilet and you see there's a float, you can able to manually lift that float, and you see water inlet will be reducing based on the height you are raising it. That we can say proportionately controlled. Okay, that's called P control. Okay, that's where the system arrive in a software basis. So it is a proportionate controller. So that's why we are saying like basic algorithm we have PI or PID. Most famous is feedback controller is PID controller. It has an excellent performance, and it is about the formulas for it, and even a combination of PI, PD or PID. That's the most common with all the constants will be placed on it. So in your system there is another gain block will be placed after the error. So it will be computed before going to the system or gain. So they called proportional gain, integral gain or derivative gain. Last time we have one k value only, but now we split the k into different k's actually. Okay, so we can able to change the values then to work more accurately. So there is a tabular column which is explaining about what will happen when you increase the k value or kp value higher or lower, then accordingly it works. This is why we can say a signal will be changing and trying to settle down to things. Okay, the most I can say, we can see all the parameters. It's nothing but TR is nothing but raising the signal. So that is the raise time. Okay, then we have peak time and settling time. That's the most common we can say is the settling time. Okay, so maybe I'll stop over here with this slide. I know you are going for a break, so go for a
Why you
break.
ask me? Huh?
But with this, yeah, can I able to resist?
This guy.
Not you.
No me.
Okay, so
I
then
know.
we are coming over.
I never
Break
asked.
about it.
He asked me. Gee,
Okay, yeah, I can
never
see all your
even know
faces.
what
Okay.
going on.
Want to change or want to have break on it. Okay, how about 8:35?